You know, when you use something like ChatGPT, it can feel like you're talking to something straight out of science fiction. It feels like magic. But today, we are going to pull back that curtain and show you exactly how it all works.
So let's start with something you probably use dozens of times a day without even thinking about it. Your phone's autocomplete, right? You type, "I'll be there in," and boom, it suggests a few minutes. It's just predicting the most likely next word. Simple.
Okay, now take that idea and just explode it to a cosmic scale. Imagine that same autocomplete feature, but instead of just knowing common phrases, it had devoured basically the entire internet. We're talking every book, every Wikipedia page, every single Reddit thread.
And that right there, in a nutshell, is what a large language model, an LLM, really is. It's not just guessing the next word. It's working with this unbelievably massive understanding of context, of logic, and even the vibe of how we humans talk.
So, how in the world does a machine absorb all of that information? Well, it all kicks off with the training process. You can kind of think of it like building a ginormous internal library of knowledge.
Let's use an analogy here. Just picture someone who spent their whole life locked inside a library that has everything humanity has ever written down, from Shakespeare's plays all the way to, the weirdest Reddit threads. They're not just reading, they're soaking in all the connections between every single idea.
And listen, this is a really important point. During this training, the model isn't memorizing facts like a student cramming for an exam. No way. It's more like a detective, looking for patterns. It learns that, hey, when the word Paris shows up, the phrase capital of France is statistically very likely to be somewhere nearby. It's all about probabilities and relationships.
But, okay, the model is being fed all this text, right? But there's a big problem. Computers don't speak English or French or any human language. They speak math. So how do you bridge that gap?
A computer has zero idea what love or justice actually feels like. It just can't get those abstract concepts. But what it can do, better than any person on the planet, is just crunch huge, complex numbers at lightning speed.
So the solution is pretty clever. You translate our words into the computer's language, numbers. Every single word gets turned into a long list of numbers, and we call that a vector or an embedding. The whole point of this process is to capture the meaning and the context of a word, but in a way a computer can actually work with.
What this does is it creates this kind of map of meaning, but made entirely of numbers. So on this map, the numbers for apple and pear would be really close to each other. But the numbers for apple, the fruit, and say microchip would be really, really far apart. And that is how the computer starts to understand relationships, purely through math.
All right, so all the words have been turned into numbers. What does the model actually do with them? Well, it turns out its main job is surprisingly simple.
At its very, very core, an LLM is just playing one game, over and over billions of times a second. And that game is what comes next. Every single complex answer it gives you is just built one little piece at a time by making the most statistically likely guess. For instance, let's take this famous old advertising jingle. If you feed this phrase to the model, it immediately dives back into that giant library of patterns that it's already learned.
And the model doesn't just find one answer. It actually calculates the probability for all the possible next words. So based on its training, it might say, okay, there's an 80% chance the next word is Folgers, a 15% chance it's coffee, and, well, maybe a tiny 5% chance it's chaos. It picks the most likely one, adds it to the sentence, and then does the whole process again for the next word and the next.
But hang on, just predicting the next word doesn't fully explain how these things can write, complex code or a thoughtful essay. There is a secret sauce that gives them a much, much deeper understanding of context. Just look at this sentence. An older AI would probably get confused here. Does it refer to the man or does it refer to the chair? Now, for us humans, that's obvious, right? But for a machine, trying to track relationships across a long sentence is actually incredibly hard. And this is where the real breakthrough comes in. Modern LLMs use a technology called a transformer, which has this amazing ability called self-attention. It lets the model weigh the importance of all the other words in the sentence when it's looking at just a single word. So it pays attention and figures out that comfortable is linked to chair, so it has to be the chair. It's brilliant.
So let's kind of bring this all together. When you combine this massive library of knowledge with that super powerful attention mechanism, you get something that feels remarkably intelligent.
And that brings us to the biggest question of all. If it's all just math and statistics, why does talking to an LLM feel so much like talking to another person?
Here's the thing you've got to remember. The model isn't thinking or feeling the way we do. It has simply learned the incredible, subtle nuance of our language. It knows what sarcasm sounds like, what a technical paper requires, or how to write a poem, all because it's calculating the most statistically probable human-sounding response from trillions and trillions of examples.
In the end, this is really the best way to think about it. An LLM is a mirror. It's reflecting the collective knowledge, the creativity, and all the communication styles of humanity, all of it processed through this powerful mathematical engine that's just designed to predict the best way to finish a thought.
And that leaves us with one last pretty big question. If this technology is just a mirror of the massive digital world that we've all created, what does its reflection really show us about ourselves?